Here we have a geometry problem on two column proof. Okay, let's go to the question. Given BD bisects angle measure ABC and also the line segment BD bisects the angle measure ADC. So the line segment BD over here bisect, that is it divides the angle measure ABC into two equal parts, and also the same line segment BD bisects the angle ADC, that is it divides the angle into two equal parts. Okay, we have to prove that the line segment AD over here and CD over here are congruent. Okay, now let's use the given information over here. So since the BD bisects the angle measure ABC over here, that is it divides into two equal parts. So the angle measure over here, that is ABD, and the angle measure CBD must be congruent because this complete angle is divided into two equal parts by the line segment BD. The same we have in the angle measure BADC, it is ADC. So this angle measure has been divided into two equal parts by the same line segment BD. So the angle measure over here and the angle measure over here are congruent. Okay, further I'm going to use a two column proof to prove that the line segment AD and CD are congruent. Okay, now let me write the required stuff. Here I have taken two columns. In the first column, I'm going to write the statements. In the second column, I'm going to write the reasons. This is called a two-column proof. Okay, my idea to solve this problem is, first let me prove that two triangles ABD and BCD are congruent. What if I prove these two triangles are congruent? If I prove these two triangles, triangle ABD and triangle CBD are congruent, then I can prove easily that the line segment AD and CD are congruent. How can I say that that line segment AD and CD are congruent? Because I can use the CP-CTC theorem. That is, corresponding parts of congruent triangles are congruent. So if two triangles are congruent, then their corresponding parts also must be congruent. Okay, now let me take the first information, that is line segment BD bisects the angle measure ABC. So BD bisects angle measure ABC. That means the angle measure ABC has been divided into two equal parts by the line segment BD. So the angle measure over here, the angle measure over here, that is the angle measure ABD and the angle measure CBD are congruent. So let me write the stuff over here. So angle ABD is congruent to angle CBD. So what's the reason for this one? The reason is definition of angle bisector. Let me write the stuff over here. Definition of angle bisector. Let me write it. Angle bisector. Now let me consider the side BC over here. It's a common side for both the triangles, triangle ABD and triangle CBD. Since BD is a common side for both the triangles, let me write the stuff over here. So the line segment BD is congruent to BD itself. So that is by reflexive property. Let me write the stuff over here. Reflexive property. Let me write it. Actually, the reflexive property says any line segment is congruent to itself, and also any angle measure is congruent to itself. So here I am saying in BD, the line segment BD is congruent to BD itself by reflexive property. Okay, now let me consider the angle measure over here, that is ADB, and the angle measure over here, that is CDB. So these two angle measures are congruent. Already we have discussed this one because BD, the line segment BD bisects the angle measure ADC. That is angle measure ADC has been divided into two equal parts by the line segment BD. Let me write the stuff over here. Angle ADB is congruent to angle CDB. So what's the reason for this one? The same thing, that is what we have given over here for this one, that is definition of angle bisector. Let me write the stuff over here. Definition of angle bisector. Let me write it. Okay, definition of angle bisector. Okay, now let me consider three components of the triangle ABD over here. So what are the three components? Let me consider the angle measure over here and the angle measure over here. And the included side, that is the side BD, is included by these two angle measures. So I consider the two angle measures and the included side of the triangle ABD. Now let me consider the same stuff in the second triangle CBD, that is angle measure over here, angle measure over here, and the included side BD, because BD is included by the two angle measures over here. So already we know that the angle measure over here, angle measure over here are congruent, and also the angle measure over here, angle measure over here are congruent. So BD is a common set for both the triangles. So BD is congruent to BD itself by reflexive property. So the two angles and included side of one triangle are congruent to two angles and included side of another triangle. Whenever two angles and included side of one triangle are congruent to two angles and included side of another triangle, then the two triangles are said to be congruent by angle side angle triangle congruence postulate. Okay, now let me write the vertices of the first triangle. So let me take the vertex A of the triangle ABD. Let me write the stuff over here. So if I take a vertex A in the first triangle ABD, what is the corresponding vertex in the second triangle? That is C. Let me write it over here, C. Now let me take the vertex B in the first triangle. The corresponding vertex in the second triangle also is the same B, because the angle measure over here, the angle measure over here are congruent. So the B is the second vertex for the first triangle, and the same B we have a second vertex for the second triangle. And now let me take the third vertex of the first triangle, that is D. The same vertex we have for the second triangle as well. It is D, and here we have D. So these two triangles are congruent by angle side angle triangle congruence postulate. Okay, now I have proved the two triangles, triangle ABD and triangle CBD are congruent. Since these two triangles are congruent, so their corresponding paths also must be congruent by CP-CTC theorem. So if I consider the side AD, what is the corresponding side in the second triangle? That is CD. So and also we can get it from the vertices of the two triangles I have mentioned over here. So to get the side AD in the first triangle, I have to consider the first letter and second letter over here. That is AD. Now let me take the corresponding side in this triangle. For that we have to consider the letters at the same position. That is first letter and third letter. So CD. So these two sides are corresponding sides and they must be congruent. I decide these two sides are congruent by CP-CTC theorem. That is corresponding paths of congruent triangles are congruent. So that is side AD and side CD are the corresponding paths of two congruent triangles, triangle ABD and triangle CBD. So they are congruent.